Hi class, this is 2015 number 6. It's one of the topics under May 5th. And it looks like a separate and integrate, but no, it's not. Now I believe the AP exam might take a separate and integrate question for like say part A or B, and then do stuff like we're going to do in this question for maybe part C or D. So this is a very important question and it uses implicit differentiation. Okay, part A says write the equation of a tangent line at the point -1, 0. Now, -1 not 0, -1, 1. So ladies and gentlemen, they want the equation of a tangent line. Two things are necessary for a tangent line: a point, and they've already given me my point. That's my x and my y, my point, and then my slope. And your slope always comes from the derivative. So to find the slope, I need to know what is dy dx equal at the ordered pair -1, 1. So my y is a 1. So I put a 1 there. There's another y, so I'm going to put another 1 there. And then my x is a -1. Now, remember this AP exam, you do not have to simplify anything. It's all free response. So, I'm going to sneeze. Coronavirus. Oh, whew. Okay, so you could actually leave that as your slope. And when you go to do your answer, you could say y minus y1. By the way, this is part A. Y minus y1 equals m. And when you get to m, you could use all that for the slope. And then x minus x1. X minus, and then you're putting a -1 in there, so it's a +1. And that works just great, and you can use that for the slope. Now, is this a difficult slope to find? No, you could easily simplify it. It's 3 plus 1, which is 4. Your slope is 1/4, and you instead could do this. But I want you to get the idea, the point, that you don't need to simplify this stuff if you don't want to. And you shouldn't. You really shouldn't. This is easy to simplify. It might be weird to write this instead of 1/4, but simplifying loses points if you mess up. All right, part B says find the coordinates of all points at which the line to the curve is vertical. Okay. Wow. Well, before I get to part B, I want to do part nope. They did not ask this, but they might ask it on the AP exam. They could have easily asked you to take this right here and prove that this was dy dx. They did not ask us to do this, but they could have. And I want you to watch, if you're watching the video, to make sure you remember implicit differentiation. If you want to, pause the video and try doing implicit differentiation. All right, the derivative of y to the third is 3y squared. We get the chain dy dx. And then here, we're going to use product rule. I'm going to count the negative with the x. So product rule first piece, -x times derivative of the second piece. The derivative of y is 1, but you get the chain dy dx. Plus the second piece y times the derivative of the first piece, which is -1. That's the product rule. And then the derivative of this is 0. Now, if you were doing implicit differentiation, anything with a dy dx stays on this side. So this has a dy dx, it stays. This has a dy dx, it stays. But this doesn't. It's a -y. I'm going to add it to the other side. It's a y. And then look what happens. I GCF out the dy dx. Oh, that's a y. Sorry. And I'm just going to divide. And if I divide, I get dy dx equals y over this. They might ask implicit differentiation. So I wanted to show that to you if you watched the video, but you're not supposed to do this on this question at all. So let's go to the actual part B, which is to find out when the slope is vertical. if a graph looks like this, that's a horizontal slope. A horizontal slope means the derivative is 0. Now, if you have some fraction, a slope being 0 is 0 over some number. That's horizontal. But if they're talking about vertical, vertical means the slope is undefined. And a slope is undefined if you get some number over 0. So this is what we want in this problem. We want it to be, by part B, we want it to have a vertical tangent line, which means we want it to be an undefined tangent line, which means we want the denominator to equal 0. Now, while this question is difficult to get all the points, you can get some of the points right away. So, you get 1 point immediately if you realize to be a vertical tangent line, the bottom needs to be 0, and if you set this bottom equal to 0, you get a point. Now, how am I going to find out, well, when does this equal 0? Well, you can't. There's an x and a y. But we're going to combine these two equations together and solve a systems of equation. So what I'm going to do is I'm going to take this equation and get x by itself. And if I get x by itself, I can now take this x and replace it up here. So here it says y to the third minus x, y equals 2. And this x right here I can now replace with 3y squared. And if I do this, I now have y to the third minus 3y to the third equals 2. If we combine like terms, one of these minus 3 of these, we have negative 2y to the thirds equals 2. If we divide, we get y to the third equals negative 1. And if we cube root negative 1, the cube root of negative 1 is negative 1. Now, this is the y coordinate. They don't just say find the y coordinate. They say find the coordinates of all points. So, we know y is negative 1. We can plug the negative 1 here or here to solve for x. I'm just going to plug it into here. So if I plug it into here, I get, negative 1 squared is 1 times 3 is 3, and I get x is 3. So I get the ordered pair 3 comma negative 1 as the ordered pair where the vertical line is tangent. That's part B. Let's go look at part C. So for part C, they want us to find the second derivative and plug in some ordered pairs. This is going to be an insanely big earn-it question. We are not going to be doing a ton of simplifying. They want the second derivative at the ordered pair negative 1, 1. Okay, well, we want the second derivative, which means we're going to have to take the derivative of the first derivative. So we have to take the derivative of this, and it's going to require implicit differentiation. That means whenever you take the derivative of y, you get the chain dy dx. So let's do implicit differentiation with quotient rule. So we start off with low d high, so low d high, the derivative of the high, derivative of y is 1, but times the chain dy dx. So that's low d high minus high d low. The derivative of the low, get implicit. The derivative of this is 6y, but we need the chain dy dx. And then the derivative of x is 1. So that's low d high minus high d low, all over low low. Okay. And now, all we have to do, and we're going to leave a big, ugly answer, is they ask us to plug in some ordered pair. They say when x is negative 1, and y is 1. So y, whenever I get to these, I'm just going to plug them in. So y is a 1, x is a negative 1, and now we get to dy dx. Now, guess what we did in part A? Go back to part A. In part A, we took the ordered pair, negative 1, 1, and we plugged it into here, and we got 1/4. So from part A, dy dx, when you plugged in negative 1, 1, was equal to 1/4. So when I get to this part of the problem, I'm just going to put a 1/4 there. Moving on, minus, my y again is 1. 6, my y again is 1. dy dx from part A is 1/4. All over 3, y is a 1, x is a -1, squared. This is the second derivative. This is the second derivative after plugging in -1, 1. There's no need to simplify it. You get your points, you're in the way. I hope you enjoyed the video. I miss you guys. Bye.